In this video, we will see how to generate histogram, column scatter plot, box and whisker plot, column with error bars, average plus or minus standard deviation, standard error of the mean, and 95% CI, XY line plot that is time series, outlier test, grubs, and route using Graphpad Prism software. So what I suggest you is to download the module number 29 of the week number 12. I hope you have already downloaded. You can see that there will be two the files. The first one is Excel practice, while the second one is called the Graphpad Prism practice. So just double click the Graphpad Prism practice. So it will show you several data table on the left side. The first one is about the PSU for the histogram uh, thing. So you will see that there are two groups here, group A and group B. As you can see that this table is the column table. That is the first option for that. So in case you would like to change the table, then you can simply go to the change the data table, and then you can go to a different set of table. There are like contingency parts of whole. This we have seen that in the last video. For this particular group, the two groups, the column is the most appropriate table, so it's absolutely fine, so I don't have to click to change it. So you will see that there are two groups here, the group A and B, and now these are nothing but PSU, or practical salinity unit, the salinity of the water from the two regions that I collected. The first one is in the Indian Ocean. The second one is in a place called the Deep Lake in the Westfold Hills. So you might wonder where it is. It is in a place called Westfold Hills of East Antarctica, the place where I have been in 36th Indian scientific expedition to Antarctica. So this is a lake where the salinity is extremely high, which is almost near to the Dead Sea salinity, around 40 PSU. And because of this extreme salinity, the lake never gets frozen, even in the mid of the Antarctic winter. And there are several interesting archaebacterial species which has been described from this very important the lake called the deep lake. Let us now consider these two things. So the salinity of the Indian Ocean as well as the group A and group B we have. Now first let us calculate the frequency distribution. So I have to click here, analyze, column analysis, frequency distribution. Which data set to analyze? Of course A and B, group A and group B. I click here, OK. Then just accept all the default values, and I click OK. So the moment I click OK, this frequency distribution is already up with the bin all determined automatically, and these are nothing but the empirical frequency. And this will also create, this is in the results section. There will be another one called graph section. So once you click on the graph, you can see a histogram already come up. So you can see that the two histograms are together plotted. So it is basically a bimodal, and the Indian Ocean and Deep Lake of the Westfold Hill on the right side. So this is the bin and the number of values. So if you would like to change the x-axis, you can just click like this, or you can reduce the size like that. And usually in the histogram, there should not be any gap between the columns, so you can change that just by clicking all this formatting. Here the options are there to format the x or y-axis. This is axis format, while this is for the graph. Let us click on this third option, format the graph, and then a small window will come up here. Let us go to the third option, the graph setting. Here you can see that between adjacent data is 50, so let us reduce that to 0. So there won't be any gap. I click OK and click OK. So you can see that there is no gap between the data. So this is perfectly fine. So you can see that it's roughly normal distribution. The two are kind of normal distribution, which is not exactly normal distribution. Let us go back to our data table, and then you can see that the instructions are on the right side. I suggest you to go with all this analysis. Next is to do a column scatter plot. How to do that? For any plotting except histogram, you will have to click here, new, and new graph of the existing data. So I click on the new graph of the existing data. It will ask you what kind of what kind of data would like to have. So there is option here, column, grouped XY. So I go with column, individual value or box and violin, or mean, median, and error. So let's go with individual values, and this is the box. This is what you call the scatter plot or column scatter plot. So what exactly you would like to plot? Mean with standard deviation is absolutely fine. So let us go with column scatter with mean and standard deviation. So you can see that two plots have already come up here. This is nothing but two columns, and the line here is basically nothing but the mean, and you can see that this is nothing but the scatter on the some values are top, some are bottom of the two groups, our PSU at Indian Ocean and Deep Lake in the West Hills. So let's go back to PSU Hist. Third one is the next one is box and whisker plot. So again, you can click anywhere and then click same way, new graph of existing data, and instead of individual value we will go with box and violin, and here we will go with the box and whiskers. Now the point here is a whiskers. Where do you want to plot? To minimum and maximum, or there are several options here. Tukey is for the Tukey's HST. That is a post hoc test. 10, 90 percentile, 5, 95 percentile, 2.5 to 97.5 percentile. All these are there. So let us go with the first one, min to max, and I click OK. So as you can see that two beautiful box and whiskers have already been created. So you can see it's a very good way to summarize lots of data, so I suggest you to present your the raw data in form of box and whisker if individual plot points are more than 100, and if it's less than 100, go with column scatter. Deep Lake is this, and PSU or Indian Ocean is this. So as you can see, the Deep Lake PSU is just little bit less than 40, while Indian Ocean is around 35 or 32. So it is a really good way to summarize the complicated data set like this. So let us also see that is it really normally distributed or not normally distributed. So let us also do a normality test. So all I have to do is analyze. So for analysis of the normality test, so there is an option here, normality and log normality tests. So I click here, normality and log normality, I click OK. So click here, the normal distribution or log normal. So let us go with the normality test. So I told you the best normality test perhaps is D'Agostino-Pearson Omnibus K2 normality test. Let us also do some other tests including Shaparov-Wilk and Kolmogorov-Smirnov, and the new test called Anderson-Darling, which I haven't described, but it's also an option. So let us choose all these things, and then I click OK. So as you can see that this is the result. So the results will come up into the next. So this is the first one is data table. The next one is the result table. This is a result table. So as you can see, there are two results. The first is a histogram which we just generated. The second one is a normality table. So this is a normality result. So the first one is this is the what we are interested in, D'Agostino-Pearson K2 omnibus test. As you can see that the p-value of the A and B are two groups. So the first group is Indian Ocean, where you can see the p-value is quite high, and for the Antarctica is also quite high. So both are quite high. That means not significantly different from the normal distribution. So did it pass the normality test at alpha 0.05? Yes. So this is a very easy way to say that is it actually passing or not passing. So p-value ns means not significant, not significantly deviating from the Gaussian normality. That is what it means. So Shaparov-Wilk test or D'Agostino-Pearson is also same, and Kolmogorov-Smirnov test is also same. So as the Anderson-Darling test. So all test says that the distribution is normal. Fine. So that is all the tests that we are going to do with the first data, that is PSU or histogram. The next one is mango tree hides the same data that we have used in the Excel. Let us do the mean and median and error of this one. So let us first, what we have to do is to generate a graph for this data. I click new and then new graph for existing data. So I just have to present, a graph for this. So here The first is individual values for scatter plot. This is box and violin. The third option is mean, median, and error. So let us go with the third option this time. So what kind of graph would you like to go? The first one is absolutely fine. This is column bar graph, also known as dynamite plunger plot. So what would you like to present? Is it mean plus standard deviation or mean plus SCM, 95% HCI? Everything you can actually choose it here. So I suggest you to try different options at different times. So let us now go with 95% HCI for the sake of brevity. Mean with 95% HCI. Click OK. So as you see, everything has been automatically put up here. So the Y title, X title, everything I can change it. So I can change the Y title by clicking heights in meters, right? And these are locations. So I can choose this way, and now this is only one directional. This is exactly the plunger plot or dynamite plunger plot. I can change by formatting the graph, and this is the data set here, mango tree heights A. So I can change all the data set together, and instead of different colors, I can let's go with just one color. Let us choose this color with the border is absolutely fine. Error bar color is fine, the color of this error bar, right? And the style is also okay. Now direction, let us go with both sides. So both up and down, and then I can apply and see how does it looks like, and I click OK. So as you can see here, I can see does it actually overlap or not just by looking at this point. So it's really convenient way to construct a box, this standard ST standard deviation or 95% CI in one click. The Graphpad Prism is a wonderful software for all these things. Excel will not let you to do this. It's a multi-step process in Excel, but in this Graphpad Prism, it's really simple. Few clicks and your results are ready. Now let us go with the third option. Third data is literacy rate in India as well as Japan. As you can see, there are two groups A and B, and both all these things are basically summary data. This is not the empirical data because you can see that mean plus or minus standard deviation with n. So it's a table is grouped format because all inside a group you can see the multiple options here, or you can go with the the summary option. So here these are nothing but the years and literacy rate. So let us go with XY plot of this. So any plot is new graph of existing data, and I will have to click here instead of grouped. I go with XY, not column but XY. So is it just usual XY you want, or you would like to go with XY with connecting lines and error bar? I think this is the perfect option for this one. Or even I can go with the usual line with error bar. So let us go with the second option at this time with standard deviation. Fine. I click OK. So as you can see, the two things have already come up. The first one is Japan from 1901 to 2011, while this is for Indian graph. So this is, you can see that this time series in thing. So if you would like to change some of these, you can simply go to the format error bar, and which one would you like to change? For example, I can choose for Japan. I can choose a color red. While let us you can apply it and see, you can see that. And now if you would like to change the color for India, I can go here and I can choose, let us say, blue for India. I can apply. So this is really simple to make a very nice publication quality graph. You can change here Y title to literacy, while this X title, if you don't want anything, just put a space, then it will automatically be deleted. And these are your these are legends, so you can put placement of the legends wherever you would like to work with. So this is a really easy way to generate the data. Now the fourth one is called PAM. PAM is nothing but pulsed amplitude modulation. which is nothing but the product of the output of the fluorimetry for photosynthetic rates. So as you can see, you will see there are four groups here, group A, B, C, D. These are nothing but labeled H31, L31, H25, and L25. This is a stress test for the algae grown at two different temperature, 31 and 25, and two different nutrient levels, high nutrient level and low nutrient level. So basically we have got four groups and we are testing their photosynthetic rates by pulsed amplitude modulations. So these are different power, that is photosynthetically active radiation. So for example, 281, what is the PAM reading? So that is what it says. So a very good way to summarize this data is for XY with the line. So just like in the case of the literacy that we did it. So here I can go with new graph of the existing data, and I can click for the third one here, XY without any points. I click OK. So as you see that the four things are very clearly seen, then I can change the color and I can change the appearance, everything I can do that. So this is really easy for generating a publication quality data by this way. Now the fourth one is that you can see that Cladophorapsis is an algae. So these are the PAM readings at L25. There's a multiple readings. So if you would like to summarize this kind of data, L25, H25, L31 and H31. So I'm just scrolling towards the right side. So to summarize this, a very easy way would be the Boxwhisker plot. So let's go with this plot for new graph for the existing data, and I can go with Boxwhisker data for this one. So let us go with the column Boxwhisker. So I can go with uh, the usual Boxwhisker here. This is the Boxwhisker, so I can actually generate the Boxwhisker. So either you can go with the Boxwhisker for the column or the grouped one as well. So you can go with the grouped Boxwhisker you can develop. So you can see that different kinds of Boxwhisker plots are there, or box and violin plots. So Boxwhiskers are there. So would you like straight or the uh, you know this sort of Boxwhisker? So let us go with this min to max. So instead of that, let us go with 10 to 90 percentile. The whiskers will be drawn to 10 to 90 percentile. So as you can see here, Cladophorapsis, so the four readings here all corresponds to L25, H25, L31 and H31. So different things. You can also spot the outlier. So it might not be an outlier. You'll have to go with a formal test. So this is a very convenient way to do to summarize the data by Boxwhisker plot. Now let us go with the next one, cell for one outlier. These are nothing but cell area measurements of a number of things that we did. So if you want to detect one outlier, I suggest you to go with Grubbs test. So how would you do that? First you have to click analyze, and to find the outlier. So outlier is column analysis, identify outliers. So this is what you will have to go with. So here route method, Grubbs test or iterative Grubbs. So let us go with Grubbs test this time, because if it has only one outlier, go with the Grubbs test. So inside the result you can see that one outlier has been removed. So as you can see that one outlier has been removed. So what is this out of 130? That is what the Grubbs alpha. Now let us see which is the outlier. Number 34 is outlier. The outlier value is 66. And if you remove this 34, this is a cleaned data. So as you can see, the 34th row has already been removed. So this is a clean data that you can use for your further analysis. So this is the way to remove the outlier using Grubbs test. Now let us go for the cell for four outliers. So in this case, there are so many outliers. So we will go with Grubbs test this time. Analyze, identify outliers, and go with the route method this time. So I click on the route. So the result data will say that the four outliers have been removed, and I click to see which are the outliers. These are the outliers along with the respective row numbers. And if you click this, the clean data, so you can see that the data you can come up with the outliers, removed outliers also you can see that. For example, 83 is already been cleaned. So this is how to do this outlier test.